Okay, so in this question, they're asking us to compare how many times larger the radius of a mercury atom is than the radius of a hydrogen atom, right? So we're talking about um, almost unimaginably small measurements, right? Here, the mercury atom, they're telling us what? They're telling us the radius is 1.5 times 10 to the negative 10th meters. So maybe from the center cluster of the atom to its outermost region of its electron cloud, right? That has a radius. That distance is 1.5 times 10 to the negative 10 meters versus the radius of a hydrogen atom, which is 2.5 times 10 to the negative 11 meters. Now the hydrogen atom, right, is smaller, and we can tell because of the way they phrase the question, but also by looking at the exponent. Here it's 10 to the negative 11th, which means, right, you're dividing by 10 one more than you are here with 10 to the negative 10th. And that means you're dealing with a power of 10 smaller, because every time you have 10 to a negative something, right, negative 1, negative 2, the negative exponent tells you the number of times you're dividing by the base, or dividing by 10. And here we'll show you that, but let's just get a little sketch, right? So the distance is smaller. So the atom's a little bit smaller, and probably on the scale that I'm drawing it right here, not even really visible, even though it is quite smaller. So we'll set them up here, and then we'll show how we can tell that one is smaller than the other using the number value system. So 2.5 times 10 to the negative 11. Excuse me. This means divide 2.5 by 10 11 times. So every time we divide by 10, our decimal moves left. So if we move 11 places from where we are to the left, we'll get this number in standard form. Now if we move 11 places to the left, how many zeros will we have? Well, one move of the decimal was taken by the 2. So there are 10 more moves to go, and therefore 10 more zeros, right? 5, 6, 7, 8, 9, 10, to fill in the gap. So this is our measurement for the hydrogen radius versus our measurement, right, for the mercury radius. And here, I'm going to, again, write 1.5 times 10 to the negative 10th. Now we have our decimal moving 10 places to the left, and one place is already taken by, by the 1. So 3, 4, 5, 6, 7, 8, 9. And in total, we have 9 zeros in total versus the 10 zeros here, 3, 6, 9, 10. And if we line these two up, if I just rewrite it over here, you can see 2, 3, 4, 5, 6, 7, 8, 9, that although 2.5 is bigger, that 2.5 refers to these smaller values because, as you can see, there are more zeros here, and every time you add a zero, you can lower the place value. So in fact, this number is the larger number. Now, why am I giving all this background? Well, I want you to realize that this question, when you're asked how many times larger is one number than the other, all you're doing is dividing. So if I was saying, how many times larger is 8 in comparison to the number 2? Well, you would just divide 8 by 2, because 8 is larger than 2, and this would tell you that 2 goes into 8 4 times, so the answer is 4. This algorithm is exactly what we're going to do here, except we need to establish at the start which number really is larger. So again, we'll use the same algorithm, and I'm not going to use the standard form. We're going to actually use scientific notation here. These forms actually make the problem quite easy. But we're going to do the larger number, which is 1.5 times 10 to the negative 10th, divided by the smaller number, 2.5, right, times 10 to the negative 11th. So here when we're dividing, I'm going to look at 1.5 divided by 2.5. And I can think of that as what? Well, 1.5 over 2.5, that's the same thing as 15 over 25. Just proportionally multiply both numbers by 10, and we'll get the same quotient. And 15 over 25, you can multiply both of those by 4 to get 60 over 100, and so you can see that's just 0.6. Or you could have reduced that, right, to 3/5, excuse me, as well, and that would help you see it's 0.6. And then what the nice part is, when you take 10 to the negative 10th and divide it by 10 to the negative 11th, since you have the same base, you just subtract the exponents. It's a nice law of exponents used right there. We get times 10 to the positive 1, right? Because negative 10 minus negative 11 is positive 1. And if they don't give you the answer in this form, maybe they want it in scientific notation, or maybe they just want you to multiply the 0.6 by 10. So what I would do is multiply 0.6 by 10 to get 6. And then if you had to write this in scientific notation, that would be 6 times 10 to the 0 power. Because 10 to the 0 is just 1, and 6 times 1 is still 6. So here really the answer is 6. The mercury atom, right, has a radius that's 6 times larger than hydrogen. So in fact, my scale drawing is way off. If this is the length right here, right, of the radius, our hydrogen atom should have a radius 6 times smaller. So if this is mercury, hydrogen would in fact be something to the effect of this right here, right, a much smaller atom. So this scale is way too large. All right, hope this helped.